Hello and welcome, everyone. Thank you for joining us today. Hello, welcome everyone who's just joining. We are going to get started right away because our guest facilitator today, Daniel Vasiliu, who's an associate teaching professor of data science, has so much to share with you. It's honestly more than we'll fit in 30 minutes, but Daniel has generously agreed to be available for follow-up questions. And of course, we'll send follow-up resources after the fact. And if you have additional questions, I think we have a little flexibility to stay on after the official 1:30
Yes,
content time. So welcome to this quick bite about accessible scientific documents. Thanks for joining us today, and I'll hand it over to Daniel.
thank you. Hi, everyone. Welcome to this mini talk. I hope you'll find the content useful. The main idea is how to make scientific documents accessible. This is a problem that I confronted a few, not just a few, but months ago when we learned about accessibility standards, and I realized that all of my scientific PDF documents that I was trying to upload in Blackboard, they were not considered very accessible by the LI checker. So that was a crude moment, a moment of realization for me. And I just wanted to find a way to make it right. And so today I would like to share my story of creating such documents. So, first things first, I'm assuming that most of you are familiar with LaTeX or PDF tech. If not, uh, I'm happy to explain a few things on what is LaTeX or Leslie Lamport tech version that was very, very popular. In short, LaTeX, it's a scripting language that was developed based on a predecessor called Tech. And basically, um, they are meant to give you a way of creating scientific documents by scripting. So instead of just having what you see is what you get engine like Microsoft Word, or having an equation editor, you are going to actually script your elements, your equations, and as such, you can also include visual elements, figures, anything that could go into a scientific paper. Um, Lua in Portuguese means moon, and the Lua language was proposed at a conference in Brazil in 1993 as a very efficient embeddable language, a glue-on language. So glue-on languages mean that Lua by itself is cute, is efficient, but may not do or achieve that much. But if you glue it to C++ or other scripting languages, this fusion achieves great potential, which means translates in allowing you efficient options for accommodating a lot of standards and a lot of project goals. So LuaLaTeX is the successor of what you may have used, such as PDF Tech or PDF LaTeX. And a few things. Why would I use LuaLaTeX instead of the traditional or the old PDF Tech? Well, a few things. I have a few bytes for you. You can use open type fonts, but not just that. You can also use the modern tagging, and you can achieve or make accessible documents. So this is the angle. We are going to show what are the elements of accessibility and how to basically apply main ideas and templates. So by using LuaLaTeX, you get good PDF files. The PDF2 standard is what you need. So when you make now documents, we just call them in short PDF. PDF is a portable document format. It was pioneered by Adobe many, many years ago. So I had my computer, my very first computer that I got, a personal computer, not a small one like Commodore or Atari. It was a long time ago in '93. And shortly after, a famous company, Adobe, proposed the PDF standard. Now, PDF 2.0 moves away from the proprietary limitations of Adobe as a corporation and is only making updates in a more, I would say, democratic or peer-reviewed way. So the standard that we call now PDF 2.0, it's no longer tied to only one single company. What you would get if you are peculiar about your PDF format, if you really insist to get the latest PDF standards, you get richer tagging models. You get access to this world of accessibility. You get to upload your PDFs in Blackboard and not worry about anything else. So, what is this idea of vendor neutral versus, what was deemed as proprietary? I put a few things. So, very few people, when they make a PDF file, may be aware that they can make a PDF 1.7, or if they are really reading some instructions or some help, they can make PDF 2.0, which is a total game changer for accessibility. So Adobe alone, Adobe is the name of a corporation, alone is deciding what happens to their version 1.7. However, the ISO committee, many organizations, and they use a peer-reviewed process with open ballot. They decide if they want to make any changes to what we call now PDF 2.0. So that being said, we are moving on to understand how the new PDF 2.0 standard can help us with accessibility. What we get uh, is what we hope for, such as richer tagging and nice visualizations. So, a few things. What would be making a big difference when you are creating a scientific document? Well, if we create scientific documents, very likely we would have to use a language that allows no contradictions, because science could be defined as a set of rules and axioms and theoretical development that's allowing you to draw conclusions without contradictions. So math definitely must be part of it. So mathematics is the philosophy of the rules and how we make them. So we can solve problems and get no contradictions. And MathML is actually a namespace, a collection of names, hierarchical structures that deal with representing math equations online. So the standard PDF 2.0 suggests that instead of previously available ways of displaying an equation, we should rather use something that's ubiquitous online, such as MathML, the MathML namespace, because this could be allowing you much richer tagging, and also you could have the equations been read out aloud by assistive technology. So if you want one simple quick bite from this slide, is that if you are using MathML, assistive technology can read the equations, can explain them to persons who maybe they need this help. So the core problem is very, very straightforward when we deal with scientific papers. We want to include some math, some equations. We may have figures as well and tables, of course. We love tables. So today I'm going to propose a 7-step fix to address all of these pillars and show that with small modifications of what you already know from the structure of traditional LaTeX documents, you can create very accessible PDFs. What we build is going to be an example, a template. So I'm going to show you how to build this. This is just a snapshot of the front page of one example I created. By the end of the talk today, I will give all access to all of these examples. I made a free GitHub repository where I can share all of these examples with you, and I can show you how to compile them, or you can modify them based on your needs. Keep in mind, we have a workflow. Here is the overall idea, mental model. The mental model for using this technology would be that you start with your knowledge of semantic LaTeX, and you are going basically to be the author. So you have to understand your role. You are the author, you are in control. So the author has to think about tagging and metadata, something that we do not normally or traditionally or a few years before may not have been thinking of. But now, if you want accessibility, tagging and metadata is key. So once you, as an author, include the correct tagging and metadata, those declarations would be read by the modern compiler called LuaTeX, and that modern compiler would build the output for you. That would be a properly tagged PDF, and that PDF file would likely achieve a high score when you upload it in Blackboard. So today I achieved scores above 94%. I was aiming for 100% if possible. If you see the checker or LI, the LI tool in Blackboard. So what you will do, you will basically script the way you want and the way you know it in LaTeX, but you would have to add some Lua, the embedding language, Lua tagging and metadata, and I will show you how to declare it. And then the build is simple. You just click a button and I'll show you what free tools you have to use. And the result would be, I hope, good. Or uh, for me, it's amazing because I was able to conquer my fear and really now make a pipeline, and I no longer stress about being flagged by the checker on Blackboard. So step number one that you want to understand is some special preamble that you have to include in your LaTeX document. So this is the preamble that would be read by Lua. Lua wants all these options to be on, tagging obviously on. You want to specify the PDF standard that needs to be UA2, and the PDF version must be at least 2.0 or above if they make any updates, but this is the bare minimum. Language, of course, English, for example, but you can change that based on your needs. Test phase, math table, and first aid. Well, this line here could be optional. You may comment it, and still you get the same accessibility standards. This is something more for experimental tools. But then the rest of it, it's absolutely mandatory. So you have to say tagging setup, and the tagging setup includes tagging for math equations, and also alternative text for figures and tables. That's super important. So you really have to have this part with the tagging setup. So this is not really very hard to do because once you have this as an example, you can copy and paste it into your documents. Then step number two, you have to use a real structure. So what is a real structure? Well, a real structure is to really involve the section, subsection, subsection, title, and so on. So you think of this hierarchical structure when you open a book, you see chapter, title, maybe section, maybe a subsection. So you have to use those reserved objects, reserved, I would say, blueprints that you use here, for example, in your scripting file, and you make objects that would be placed in the right place on the page. And if you really are peculiar about maybe not liking the color of the font, I was playing around with different colors that so I can define what main blue or dark green means. I like colors in a document, but this doesn't mean that the document would be less accessible. So step number 3, you want to make math navigable. What does it mean? Well, it means that if you include equations like this, you would want to use the environment begin equation for displayed equations, and such environment allows you to put labels that would be read by the Lua Gluon language, and these labels would translate into the PDF 2.0 standard. So here, again, I will make a point. Instead of the double dollar sign context that we were used, we knew it's possible to achieve a displayed equation if you script with a different syntax, such as the double dollar sign. I would say no, that's actually a bad idea for accessibility. I would highly suggest you are using begin equation and end equation when you are scripting, and please be nice, include some label that's kind of describing what equation is here. So I should have said actually gradient-based updates for the equation I was tagging. Let me explain something interesting, and then I'll move on a bit faster so we don't run out of time. If you do not include such label to describe the equation, still MathML has a fallback mechanism on a default way of translating the equation into words. So that equation would still be read to a person who needs such help. However, the label you can declare adds an extra precaution, or actually allows you the opportunity to put your own interpretation of that equation. So I highly suggest that this is a very good idea to follow. So I put some do's and don'ts. For example, what you want to prefer when you are using equations, displayed equations, you want to prefer, you really want to use the begin equation, end equation environment. You want to include labels. So this is what you should do. But here is what you should avoid. You should not use the double dollar sign context. I think we have a question, or maybe not. Okay, so good. So if we do double dollar sign, we will get in trouble. But if we do this, the PDF 2.0 would be accessible. And what you write here, for example, the equation means gradient-based updates would be also read out loud by accessibility technology. Now, step number 4. Tables. We need tables because we like to see some organized information. And the secret for tables is very, very simple. I know I put a lot of stuff here, but essentially, for the secret for tagging tables is to tag the first row and to embed a tagged PDF setup with the table header rows one. So here the idea is, if you are tagging the first row, which means it's assumed to be the name of the columns, then the table would meet accessibility standards, because then the idea for accessibility technology is to say, for instance, or a screen reader would say column, for example, you can say the column, the second column, such as why it matters. Then the reader would read the values or whatever information is in that column. So for tables, again, the fix is simple. You have to tag preferably, I mean, if you can, the first row, and you are tagging basically the name of the columns. What would be that like? I mean, do I have an example of such? Yes. I will show that in the workable document that I share with everyone. So this is an example of table with accessibility. You can also, not can, but you should actually reference the table, and then the first row here becomes the required tagging. So the name of the first column is checked, the name of the second column is why it matters, and the name of the third column is example in this file, and so on. So then step number 5. I know everyone likes visualization. So we have two options here. We can script visualizations. We can script our own geometry figures. We can use TIGZ. Again, this is doable. Of course, I'm not going to go over the syntax of TIGZ. The idea is to include alternative text and tags with the TIGZ figures, which something that I will show. So here is an example of my figure slide that I have in my example. But let's move on, because we have time to talk about that technicality in a concrete way. So step number 6 would be, if you use PNGs or JPEGs or images, they need tags too. So I just put an example where you want to use an include graphics context. And the key here is that you must insert tag, the directive tag, and you must maybe, or at least for the bare minimum, highly recommended to include alternative text, which means a description of what the person should see in the image. So this is the secret for tagging figures or that you import as PNG files or JPEGs. So when you write alternative text, of course, I don't need to insist too much. You understand what better and weaker means. Alternative text is that text that the person is supposed to listen or read or understand from the description. So those are good practices. And at the end, step number 7, the last step that I'm going to insist on for making 100% accessible documents, is the references and navigation. Now, in the PDF 2.0 standard, we can have clickable elements, and when you reference something, if you reference it correctly, and here is an example of how to reference and tag, you can click in the PDF file on that reference, and it will automatically move on in the right place. So I would like to show what would be the overall validation workflow, but I will share the documents with you, and I want everyone to participate. I included on the slides common failure modes, but this is some kind of boring information because I feel I already talked about this. I just included on the deck of slides out of precaution, just to make sure you all get the message. And I have a few lines at the end of how to extend the template, but if you don't want to extend the template I'm going to share, this is going to be versatile enough and I think good enough, covers a lot of situations, so you don't need to worry about. So let's look at the right stuff here for my last slide where I have questions. Here we go. This is my GitHub repository. I hope it's visible now.
Yes,
And
we can.
you will see I can make it bigger like this. So I put two folders. This is totally free. It's a public repository. Everyone can freely download any stuff that I put here. I have two simple folders. If you go to the general document template, I made the document LuaLatex.tex. So you only need to download this file. The rest of the files should be created by the compiler. So you don't need to download anything but the .tex file. This is the file that you want. And for the presentation, absolutely the same idea. So if you want accessible William and Mary slides and you want to make them into PDF 2.0, you can, for example, download William and Mary accessible LuaLatex presentation.tex. This is the only file you need to download. But please do download the logo assets because these are our official logo and cipher and emblem. So you must download these files as well. Um, Let me, in the end, if I may, show you how I would compile or interact with LuaLatex in Text Studio. So I'm using Text Studio for, it's a free tool for editing such files. And I have it here. And I would like to share my window with the Text Studio at the end to show how this could be compiled, how you can easily modify them and basically customize based on your needs. I promise to be brief. I apologize if I go over for a few minutes. I just wanted to show what you need to do to compile. So you see in my documents, I have the explained document metadata. This is the Lua part. This is for the Gluon embedded language. I commented test phase to show it will still work if you comment that. The rest would be very familiar to you because it's just a bunch of color definitions. And then when we have equations, we prefer the begin equation, end equation. And I can tag every equation I display. The inline equations may not be tagged, but by default, because I'm using MathML and PDF 2.0, they would be read by assistive technology. So the big secret behind all this is the magic you get with math markup language or MathML. That is the big secret for accessibility for scientific documents. So this is pretty boring because it reflects what information I have here, and you are probably very familiar with LaTeX. So I don't want to insist on what you already know. But before I conclude, very importantly, when you are compiling, the option that you want to include. So one sec. So I get to the option and I will basically wrap up my presentation. So for options, I don't know if you see where I move my mouse. You click on Configure Text Studio. I hope you see this window that just popped up on my screen. And you
Do
choose the.
not see a pop-up.
Oh, okay. So it's because it's the same. I would have to reshare again, but let me see if this is still possible. This is tricky to do because it's a program and I'm using, it's an app. I'm using the menu of this app, and the menu is not, it's kind of a different overlay of the program. So I may not be able to do it, but if you navigate to your build, you have to use the default compiler LuaLatex. So here, let me see if I could put back the controls. If I'm not really sure if I can. Okay, panel configuration. And one sec, I'll try to make it visible. If not, I can show everyone this in person. So let me very quickly show this. Now you see this window that just
Yes.
popped up, right? So all you have to do, you have to choose build. And here, default compiler, you choose LuaLatex, because if you keep the PDF LaTeX, it will not work. So Keep in mind, LuaLaTeX is your friend, and the rest could be default. You say OK, and now I would reshare again, one sec, and show how to compile this. So allow me very quickly to go back to Text Studio, and simply all you have to do is just click on the Run button, and this is compiled, so process exited normally. When you look at the files, you see exactly all those many files that I shared with you all on GitHub. So to do a document, to create a document, you only need the .tex file, the scripting for what you need to say or have. The compiler, the LuaLaTeX compiler, creates automatically everything else. And the PDF you get, it's by the standard. So now if you trust me, you compile your own, upload it into Blackboard, I guarantee that this would be rated 100% accessible PDF. The presentation is in the same vein. I just, before I conclude, this is the very last idea I wanted to talk about today. There is a secret for slides or presentations with LuaLaTeX. Unfortunately, you cannot use Beamer. Beamer has some glitches. If you use Beamer, I went in circles for a couple of days. I could not. I looked online, and I realized that Beamer is becoming obsolete. So I'm using LTX Talk here. And I declare this package somewhere around, but you will find it in if you download the tag file. So LTX Talk replaces Beamer. It has all those bells and whistles, but it's nicer. So now I can compile the example of presentation. So I call this accessible presentation. I wanted to include the colors of our college. You can have table of contents, you have all the elements, but I should stop here and thank you for listening to my presentation.